Consider the following problem. You are given an array and you want to sort it in increasing order. One way to do this is to repeatedly compare adjacent elements like the following. 4 is less than 7, so I keep the array the same. And then 7 is greater than 2, so I want to swap them to get 4, 2, 7, 4, 3. And then now we compare these two elements. 7 is greater than 4, so now we swap them, and now the array is 4, 2, 4, 7, 3. And finally, 7 is greater than 3, which means we should swap them, and now we have 4, 2, 4, 3, 7. Notice that 7 is the largest element, and it is at the right. And when we perform this again, 4 is greater than 2. So then now we swap them, and we get 2, 4, 4, 3, 7. And then 4 is, equal to 4. So then doesn't matter whether we swap them or not. And then 4 is greater than 3 with these two elements. So then we swap them to get 2, 4, 3, 4, 7. And we don't need to compare 4 and 7 because we already know that 7 is the largest element. And now we have the last two elements sorted. And then now 2 is less than 4, so we don't need to change it that time. Then afterward, 4 is still greater than 3, so we have to swap them to get 2, 3, 4, 4, 7. And we already fixed the last two elements, so we're done with this pass. So now the last three elements are sorted. And then finally, 2 is less than 3, so we know for sure that the last four elements are sorted, and because there's only 5 elements, we know that all 5 elements are sorted. The process we just did is called bubble sort. Bubble sort works by swapping adjacent elements if they're out of order. And in each pass, we shift or bubble the largest element to the end, as you see here. So 7 starts as the second element, goes to the third, fourth, and fifth. Each pass, we basically just bubble the largest element to the end and then ignore the largest element for the remainder. So after one of those passes, 7's the largest element, and we only consider the first 4 elements. Then after another pass, now here 4 is the second largest element. And then after a third pass, we have that 4 is also the third largest element. And now finally, we're done. Let's implement bubble sort in Java. So in the example array, we have 5 elements and we need 4 passes. And this is because each pass fixes one element, and then after 4 passes, we fixed 4 elements at the end, which means we fixed the 5th element. The first pass fixes the largest element, and the second pass fixes the second largest element, and so on. So in general, when the array is of length n, we only need n-1 passes, each pass fixing one element. So let's make a for loop that runs n-1 times, or actually arr.length -1 times. Now let's look at what each pass does. We first compare the elements 4 and 7, then they're fine, so then we compare the elements 7 and 2, and then later we compared the elements 7 and 4, and finally we compared the elements 7 and 3. So we basically compared the first and second elements, second and third elements, third and fourth elements, and fourth and fifth elements. So in general, we keep on comparing 2 elements at a time, adjacent elements, until we reach the end. But of course, we don't want to do that every single pass because, we have, for example, in the second pass, we don't need to compare 7 with anything because we already fixed 7 in the first pass. In the second pass, we only need to compare the first and the second, second and the third, and third and the fourth. So first, we obviously need a loop for this. So let's make a for loop, starting from 0, which is the first element, then going up to, so when pass is 0, or the first pass, we go up to arr.length minus 1 for checking. However, we don't want to go all the way up to arr.length minus 1 here because we're swapping elements j and j plus 1. So instead, we go up to arr.length minus 2, so less than arr.length minus 1. Next, we notice that that's only what happens when I is 0. When I is 1, for example, we have to check one less element. When I is 2, we have to check two less elements, and so on. So in general, we should make j run arr.length minus 1 minus I times. Then each time, we check whether the two elements are out of order, and if they are, then we swap them, and otherwise we don't. So if arrj is greater than arrj plus 1, that means that we should swap them because we want this array in increasing order at the end. So then we just do int temp equals arrj equals arrj plus 1, arrj plus 1 equals temp, and then we're done. So then when we print the elements of the array, we should get that the array is sorted in increasing order. As shown below, 2, 3, 4, 4, 7. Here's an exercise. Create a method that takes as input an array of int and sorts it with bubble sort. So for this one, we create a method, so public static, and we don't want to return anything, we just want to sort the array. So void, remember that if we modify the array inside the method, then it will modify the array outside the method. So just name it bubble sort and take as input an array of ints. And then afterward, we just have to copy the code for bubble sort. And then we're done. So if instead we call bubble sort of arr and then comment this code out, it should give the same result. The next exercise is to do the same except for an array list. So for this one, let's just copy the code for bubble sort. And obviously for array list, we need to import it. So import java.util.star. Then afterward, down here, just change all instances of array to array list like so. Array list of integer, arr, and instead of length, it's size. Instead of length here, it's size. Instead of brackets, it's .get. And then over here, instead of doing array j equals array j plus 1, we do instead arr.set location value. And then same thing here, arr.set j plus 1 comma temp. And then we replace these brackets with .get. And then we're done. So when we call this method, let's just say array list of integer list equals new array list of integer, and let's just add a few elements. And then when we call bubble sort on list and print the list, note that we can directly print array lists. Then when we run it, it should be sorted as shown below. Another way of sorting an array is selection sort. Selection sort is selecting the least element each time and then putting it at the beginning. So for example, in this test array 47243, we select the least element, which is 2, and now we swap it with the first element. So now it's 2, 7, 4, 4, 3, because 2 and 4 were swapped. Then afterward, now disregarding the 2, which means we're looking at the remainder of the array, 3 is the smallest element, so we swap 3 with 7 to put 3 in the second location. So 2, 3, 4, 4, 7. So now 2 and 3 are fixed. And now next, 4 is the smallest element, so, well, we don't have to do anything in this case. Then again, 4 is the smallest element, so we don't have to do anything in that case. And then we're done. So basically each time we select the smallest element and put it at the beginning until the array is sorted. So basically selection sort is putting the smallest element at the beginning, then afterward looking at the rest of the array and doing selection sort on that one. Now let's implement selection sort. So for this one, we do, well, we have, again, we need n-1 passes where n is the length of the array. We go from 0 to n-1. So basically, we execute n-1 passes as shown in this for loop right here. Then each pass, what we have to do is basically put the smallest element at the beginning. So first of all, we need to find what the smallest element is. So let's use a variable to keep track of that. So smallest equals say integer dot max value, which is the maximum possible value of an integer. And then afterward, we search the array for a smaller value. So if ARRJ is less than smallest, then smallest equals ARRJ, and now smallest is the smallest element, because each time I'm setting smallest to be itself if ARRJ is not small enough and ARRJ otherwise. So basically we're choosing the smallest element. Now this is still incomplete, and the reason why is because, well, two reasons. First of all, we're searching the entire array, which is not right, because we really only want to search from I up to n-1, because, for example, over here, when we're already done with 2, we don't want to like say 2 is the smallest element, next pass, 2 is the smallest element, and so on. That's not good. We want to progress. So therefore, we disregard the 2 in the second pass, 3 is the smallest element, disregard the 3 in the third pass, and so on. So now, another thing we're lacking is that we still can't swap the elements. All we have is the smallest value. We also need to keep track of the index. So let's keep track of the index of the smallest value. Initially set it to something. Then whenever we update the smallest, we update the index as well. So index equals j. Then afterward, now, all we have to do is swap the element at position I and the element at position index, because, well, the element at position I is the beginning as far as we're concerned, and we're swapping that with the smallest element. So int temp equals ARRI equals ARR index, and then finally ARR index equals temp. Then when we run the code and print the array, we should get that the array is sorted once we define n, of course, to be ARR.length, as shown below. Another way of sorting an array is insertion sort. The way this works is each time you insert a new element into its proper location. So for example, in this array 47243, first step, we just have 4 and then the rest of the elements 7243. Not very interesting. The second pass, we try inserting 7 into our already sorted portion of the array. So in this case, it's just 4, 7, and then 2, 4, 3 at the end. Then we insert 2 into the array, so we have 2, 4, 7, and then 4, 3. And then we try inserting 4 here into the array. So 2, 4, 4, 7, then 3 at the end. Then finally, we insert 3 into the array. So 2, 3, 4, 4, 7. And the array is sorted. So each pass, we're basically keeping one more element sorted. So our sorted array is growing in size each pass. Each pass, it grows by one element. The first pass, we have that in the first element, we have a sorted array. In the second pass, the first 2 elements is a sorted array. In the third pass, the first 3 elements is a sorted array. And so on until the last pass where, well, the entire array is sorted. Let's implement insertion sort in Java. So as shown earlier, we need n passes, where n is the length of the array. Then in each pass, we basically need to insert our current element at index I inside our already sorted array from indices 0 to I minus 1. So what we're doing here is let's just do int j equals I minus 1. And j is greater than or equal to 0, j minus minus. So this basically goes through every element, starting from right before the element we want to insert all the way back to the beginning. And basically the idea here is that first, for example, in this pass, 7 right here is greater than 4, so 4 can't go after 7, it must go before 7. Then over here, 4 is, equal to 4, so it can be inserted there. Another example here, when 3 is inserted, 7 is greater than 3, so 3 must be inserted before 7. Then similarly, 3 must be inserted before 4, and before this 4 as well. So one way to do this is to just bubble 3 all the way back to its proper location. So basically we see that 7 is greater than 3, we just bubble it there. So for example, 2, 4, 4, 7, 3, then 2, 4, 4, 3, 7 because 7 is greater than 3, then 2, 4, 3, 4, 7, then 2, 3, 4, 4, 7. Then we realize that 3 is greater than 2, so it's in its proper location. So we'll do this by doing if ARRJ is greater than ARRJ plus 1. So basically, if our current element that we're checking is, less than the element right before it, then we just swap them. So int temp equals ARRJ equals ARRJ plus 1, ARRJ plus 1 equals temp. Then otherwise, we reached our destination, we break. Then that breaks out of this loop, remember, not the outer loop. And then we're done. So now, when we print our array, it should be sorted. As shown below. Actually, let's print our array after each iteration just to show you what it would look like. So basically, it would look like this, where, the first pass, we have 4 in its sorted location. The second pass, we have 4, 7 in its sorted location. Third pass, we have the first 3 elements sorted. Fourth pass, we have the first 4 elements sorted. Fifth pass, we have the first 5 elements sorted, and that's our final result. Let's take a look at the runtime of these sorting algorithms. So bubble sort, it's pretty simple. The outer loop executes n times, where n is the length of the array, and the inner loop also executes on average n times. So this thing is just, bubble sort is just O of n squared. Which is short for saying that bubble sort takes a quadratic amount of time to complete in terms of the length of the array. And what that means is that for arrays of length, say 5,000, it is okay. for example, but for arrays of length, say 500,000, that's not okay. Next, let's take a look at selection sort. So basically selection sort, the outer loop again runs n times, and the inner loop runs n times because we need to search for the smallest element. So then overall, selection sort is O of n squared again, quadratic time basically. And again, it can't sort arrays of length, say 500,000. Next, insertion sort. For insertion sort, we have a loop outside that executes n times, and inside it executes up to n times. And in the worst case, well, on average, inside would be n times. And it turns out that on average, it's O of n squared, or quadratic, if the array is not nearly sorted. And it's O of n if the array is nearly sorted, since we don't have to bubble as far. We don't have to bubble our element back as far. And in the extreme example where the array is already sorted, for example, this array would just break in the first iteration and it would just be linear.